In section 4.3, we're going to move on to quadratic functions. So, the difference between quadratic functions is it has the x squared in it. Meaning, we have f of x equals ax squared plus bx plus c. And this f of x is our y coordinate. And then all of our x's is our x coordinates. Now, the only rule with this equation is that a cannot equal 0. A cannot equal 0. So that first number can either be a 1 or an invisible 1 or 2 or 3. Because if a was 0, then that x squared would disappear, and then it's just a linear function. And that's not what we want. We want a quadratic. So the quadratic, as you can see from the graph below, it is a U shape. So that U shape is called a parabola. Now our U shape, there are two different ways we can have. We can have an open up. So this is an open up. Or we can graph our U shape facing down. So opening down. So those are the two ways we can open up and open down. Now, the vertex is either the lowest or the highest point. So look at my little drawing from open up. Right here, that lowest point, that would be this vertex. And then the next graph right here, this would be the highest point, and that would be that vertex. So where do the two sides meet for the lowest or highest point is your vertex. Now, looking at the graph, here's an example. We have our vertex here at the lowest point. We have our y-intercept. So where does our parabola touch the y? And then we have two x-intercepts. So where does our parabola touch the x? Now this dotted line in the middle, that's the axis of symmetry. So that just means if you went to fold the graph at the vertex in the middle, that the two lines would be perfectly matched. All right, so let's look at our x-intercept cases. So now sometimes when we graph, there are no x-intercepts, and that would look like this. So we have our x, our y. So that's if our parabola is open just inside of the quadrants, and it would be no x-intercept. Now, one x-intercept, that would be if the parabola opened up on the x or opened down on the x. So that's when the vertex is on the x-intercept. The vertex is on the x-axis, the x-intercept. It's the same. And then when are there two x-intercepts? So that would be similar to kind of what we just did, this example over here. The example on the left or the rough draft drawing that I'm showing you. Now, how do we know if the parabola is going to be open up or open down? Now, to look at that, I'm going to write that right here. So how do we know if it's going to open up or down? Now, when we have our ax squared plus bx plus c, this a, if the a is positive, then it's going to open up. If the a is negative, it's going to open down. So if that first number is positive, our parabola is going to be up. If that first number is negative, our parabola is going to be opening down. So that's how you know which drawing. You can kind of check yourself in that way. All right, finding intercepts. So to find the x-intercept, we're going to make the y-coordinate equal 0. So to find the x-intercept, our y is going to be 0. To find the y-intercept, we make the x 0. They're opposite. So let's use the quadratic function below. For example 1, find the x and y intercepts. So the x-intercept, let's first plug in y equals 0. That's the harder one. So remember, this is really our y, right? So 0 equals 2x squared minus x minus 1. Now, what does that look like? What factoring method are we going to use from the last unit? The AC method. Multiply your first and last. 2 times negative 1 is negative 2. List all your t-charts, factors for negative 2. Now the middle sign goes to the higher side, so because they need to subtract into a negative 1. So 1 and negative 2 make negative 1. Now we're replacing the middle, remember? So you need to put x's behind those two numbers. So 0 equals 2x squared plus x minus 2x minus 1. We were rewriting the middle with our two new numbers. Now it's a 4 term, so that's grouping. Group the first two, group the second two. What do they have in common in the first group? Well, they both have an x. That's our GCF. So we're going to divide x from the first group. 2x plus 1. Remember, that doesn't cancel out. There's really a 1 there. Nothing cancels out when you're dividing. And then bring down that middle sign. 2 and 1. What do they both have? Well, they both have 1. Everything has 1. Now, it's not positive 1 anymore. That sign changed it to a negative 1. So divide negative 1 on both sides. So I have 2x and then two negatives make a positive 1. Do my parentheses match? Yes, they do. So I need to bring 1 down. And then I'm going to combine the GCFs for my second group. So what was that first GCF? That was an x. And what's my second GCF? A negative 1. So we're not done because they have that equals 0. Remember, you need to set each parenthesis equal to 0 and solve for x. So I have 2x plus 1 equals 0 and x minus 1 equals 0. So solve for x. I'm going to subtract 1 on both sides and then divide by 2. So for my first x is negative 1/2. So this is really negative 1/2, comma 0. They're points we're graphing. And then add 1 for your second equation. So this is actually x equals 1, positive 1. So positive 1, comma 0. So those, I have two x-intercepts. So my x-intercepts are negative 1/2, comma 0, and positive 1, comma 0. Now let's find our y-intercept. So go back to the equation, but instead of x, plug in your y. So y equals 2 times 0 squared minus 0 minus 1. Well, 2 times 0 and 0 squared, that's 0. Minus 0 is 0. So my y is negative 1. So make that an ordered pair, 0, comma, negative 1. So my y-intercept is 0, comma, negative 1. Two x-intercepts and one y-intercept.